Hello folks, we're going to be doing an Amstrad as promised. There's another two Amstrads I think on the way. Just going to move this away for one moment. We've had some more information come. David, who's relatively local to me, sent me a link to a magazine article on this in the 80s, so we will return to that. So we won't throw it away. Got the on the air test, I don't know which gets published first, whether that gets published or the discussion on that, or our road trip to Worksop, or Amstrad 901. That's a grubby front, isn't it? So one of the things we need to do is to replace this. I'll do that at the end. I'm going to open it up just in case there's any shenanigans. The customer sent a standard replacement mic. It's a Palmer branded one. We'll be using our standard replacement mic. And Simon from Brickvex in Holmfirth liaised with me to give me back my Amstrad 901 I lent him, because he's had brackets made copied just so. So they'll be available from him for replacement brackets. We've got the power leads, he's got the brackets. What a good team. I think this set's been smoking. It's cigarettes, not blue. So it's got the bigger ballast resistor, but these are still only 3 watts. Or is it? Yeah, it's 3 watts those. So, usual thing, if we can't get 3.5 watts out of it, we'll change the ballast resistor for a better wattage rating. We'll connect it as it is. This is right at the top of its travel, so let's hope we can get it somewhere near frequency. I've just switched the test gear on, so that'll be half an hour before we have any accuracy of frequency, but we can have a look. Where's our standard replacement mic? Oh, that's a great one. We don't want that, do we? I'll go and find the Cybernet standard replacement mic. Yeah, Cybernet one. So once again, the only Amstrad thing about these radios is the name on the front. It's a Cybernet 002F, and there are fake versions of these which say made in Hong Kong, and if you come to one which hasn't got screen printed circuit board, then that's one of the fake ones. Can I show you what I mean for those people who are new here? Can we find a printed circuit board that doesn't have screen printing? Well, of course we won't be able to, will we, just at the drop of a hat like that? A board with no writing on it is what I'm trying to tell you. No, nothing here. Right. Power it up. 13.8 volts. Okay. We're on channel 20. So I'll plug the extension speaker into public address. Switch public address on. No, that one. And let's see whether I come out through the speaker mounted on the wall. Tend to sing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Well, straight away we've got a dirty volume control. I don't want to clean these willy-nilly because you're ending up chasing out lubricant. Let's try that again. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. I'm going to test the tone control. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 1, 2, 3. It doesn't have any effect on that. It probably doesn't. It's probably just on CB. So that's that done. So I've brought my sheet of paper here to write all these things down, and it's not here. Right, that's that. So PA works. We'll tick that off, even though we haven't tried them all. Vol control dirty. 1st of May, May Day 25. Amstrad CB901 Japan. Come with the serial number later. Right, we'll change that into the extension speaker socket. Yeah, tone does work. Switch picture in picture on. So we're on the 3 watt scale. Channel 20. Key up. It's doing 2.7 watts. Channel 1. 2.7 watts. Channel 40, 2.6. Back to channel 20. Current consumption 1.149 and low power we'll be generous and give it 300 milliwatts. Deviation for what it's worth on this test set. I'll just have to retune it because we're in CPT last. 1, 2, 1. It's reading 2.8, so it's too high. We'll be doing the VCO, but first of all, we'll just see where it is frequency-wise. And as I said, we will need to have this stable, but I doubt it'll even go as high as it need to. I think we're going to be changing the crystal on this. That's not acceptable. I really do think this is the top of its travel. It needs to be over 100. It's supposed to be 79125. It needs to be over 100. It's not going to do it. That is the absolute top of the shop. So we'll carry on with the tests. So 2779080. We'll put that down. I know it was a bit lower than that. So next we need to set the signal generator to the same wrong frequency. So 2779080. Right, we'll swap that now for the test equipment speaker. We need to add an earth to this radio. I have to have these isolated because some sets have an isolated chassis like this and some don't. There we go. So go with the cyanide meter. And we've got 0.3. Very good. And 0.25. And if it does 20, which I bet it does, 0.7. So that's very good on receive. Check the squelch, full squelch. Let's go with the attenuator, see what I'm doing. 100 microvolts is what I'm looking for it to open. So 1, 3, 10, 30, 100, it's not opening. The squelch never opens. Never opened. I mean, some radios are like this, but these aren't. So we'll do the opposite. We'll park the test set at 0.3 of a microvolt, turn the squelch down on the radio, set threshold, signal generator back on, straight in at 0.3. Yep. Sensitivity's there, but the top thing's ridiculous if it never opens ever. So when on transmit, when we key up, what does the meter say? Are we still on low power? I think we are. Yeah, pain these switches. It's reading 5, which it shouldn't do for a 3-watt output. And on receive, we should have 100 microvolts indicating S9, and look at that, it does. Absolutely spot on as it should be. Doesn't have a meter lamp, switches work, sockets work. So we've got to see whether we can tune this to be greater than 3.5 watts, if not change the ballast resistor, and then we've got to sort out the problem with the frequency being well out of tolerance. It's not illegally out, but it's going to start being noticeable. We can't let it out like that. I'll do the VCO first. If I remember rightly, it's 2 volts on channel 1. Let's see where we are. So in receive, at the test point there, which is the far side of the capacitor there, we've got 2.18. It's just not showing you the meter quite. 2.18. So I don't need to alter that. We've got glare on that, haven't I? That a bit better. It's going to transmit. I can't even see it saying anything on the meter. And on transmit, it's 1.94. So they're so close to 2 volts that I won't be changing them unless it's way out on 40. So it should be somewhere around about 4-ish. 3.5, 4. That's absolutely fine. So the receive adjustment, if it isn't 2 volts on channel 1, is there. The transmit adjustment is the trimmer capacitor there. So that's a good result because they're often out. And if they are out, you end up with channels dropping off, like nothing working under channel 3 or nothing working over 37, something like that. Right, so we now go over to the main meter, see whether we can get a bit more power out of this. It's lived a very easy life, hasn't it, doing 2.9 watts. So checking we're on channel 20. We want the centre of the peak. That's the centre of the peak. That one was spot on. That one wasn't spot on. Soldering iron isn't on. That was handy, wasn't it? So we'll just wait eternity. And this core, don't do this with polythene ones. That's made no difference. And the final one here, just around the ballast resistor, is where we should be able to set the power. Well, that's a bit better, isn't it? It's doing 3.4, so it's not doing 3.5. That's my cut-off point. So we'll change the ballast resistor. So the resistors we put in are 6 watt rated, so that gives it a bit of latitude, doesn't it? I think I just saw a potential dry joint. I'll also clean the board with isopropyl alcohol when we're done. So we know the new resistor. I had to order these when COVID was going, and it was 9 months delivery. Did I have a baby in that time? No, that's a slightly different value. That's higher value. There's just the odd occasion when they're doing too much power, so we need to pop in a bigger value one. That's what that is. It's 3.3 ohms or 3 ohms or something. We put 2.9 in. There we go. That's the one. There we go. I'll just clean that on my jumper. Take the sister flex tubing off the old one. It's kind of fiberglass heat resistant. Good. So we'll now retune the bits here. Make sure that's at peak. Oh, you've already done that, Mr. Tango, but you see, I've got to recheck it because we've got a different part in. We're now doing 4.3 watts. Drop that to bang on 4. And there we go. Let's check the other channels. Channel 40, 4 watts. Channel 1, 4.02 or something. Current consumption on channel 20, now 1.220, 1.220, so we've gone up, to 500 milliamps, and we've gained another 1.3 watts, so a third more power for a tiny amount more power input, so it just goes to show when it's tuned right. Now, of course, this low power is just done with some resistors, so it's not adjustable. Let's see what we've now got. We've actually got, it's just actually over what's supposed to be. It's 420 milliwatts. Now that's within a 10% correction, isn't it? You know, it doesn't matter, and it's not a legal requirement anyway anymore. But it's nice for them to work. This works really well. So it's doing a full 4 watt output. It's doing 400 milliwatts on low power. Let's get the meter set so it says 4 watts on the front and not banging across as it was. So that's power meter. Go back to full power, of course. Try again. So not banging across. So there we go. And on low power, usually these show 1. Remember, this is into a dummy load. We keep having this question. When I put this on an aerial and key up, we know it's doing 4 watts into a dummy load. If I put an aerial on it, it might read 2, or it might bang across, but it's still doing 4 watts because what it's reading is relative to the SWR. Now, modern sets, most modern sets, don't use a relative power meter like this. It's just pre-programmed bar graph, which the computer, when you go into transmit, just puts so many bars up. You can take the transmitter parts out and the thing will still read it's transmitting, which is BS. So at least it's done the right way, but not everybody gets the fact that it's relative to your SWR and a lot of other things too. I think we'll worry about the frequency next because I want the other instrument to warm up. Let's go back to the frequency counter, and I'm trying to find a cheap Chinese crystal that works. It is not easy. We'll do that first because they're cheap, and then we'll be having to look at what we can spot in second-hand junk. What are these? They're crystal filters. That's a mic on the floor. Start by taking the crystal out. So the drop with frequency, same applies with watches and colour televisions, anything else with crystals in. Just find it the other side of the board. So we've got the thing there. That's going to be it. No, it's not. That's going to be it. It is. very quick soldering crystals. They will die if you heat them more than a few seconds. Now we've got some kicking around on the bench here. This is one which has come out of an Amstrad, so I'm going to power it up. We'll just see whether we can get anything out of this one. If they're no hopers, then they're not going to be on the bench. Right, so the next thing we'll do is see if we can find one on a scrap chassis. This is where we find illegal AM sets of use. That's had the crystal taken. Lost these, have the crystals gone before I get my hands on them. That's gone. That's gone. Probably about 1 in 20 sets with a Duff crystal these days, which are, you know, obviously 40 odd years old, aren't they now? Now that is going to have to cool down, but we can set it, well, hopefully by not dropping the tools. We can set it somewhere near. So it's just slightly high at the moment, but it's hot and all that. Right, that'll be about there when it's settled. Now I'll reset my signal generator to be still off frequency, but this time 79145, which is where we are. So we can carry on while it's cooling down. The first thing we'll do is the detector. Hello? Where's that gone? It's dropped off, that's why. So over to the oscilloscope. And find out where our maximum recovered audio is on the detector coil. Wow, that's an improvement. First of all, I'll do the... Just going to knock the meter up so I can see the meter, the cyanide meter and the oscilloscope all at the same time. So we do the IF, intermediate frequency. I'll go with the cyanide meter because that's what I'm going on mainly. Good. Right, now we'll just go solely over to the cyanide meter. Do the front end. There we are. Now, because the because the detector was out, we may find the radio is now deafer. Let's hope not. 12 dB, 0.26. Ah. 0.1, sorry, 10 dB, 0.22, and 20 dB, which will have improved, 0.5. Good. Well, that'll get him another 10 yards range. Squelch. Oh no, do the meter next. So of course all that's out the window because it was spot on before. I've had to adjust it as part of the alignment. So we've got 9 showing for 100 microvolts. I'm going to move the signal generator up and hope it goes to plus 30. I want it to do that, so I'm just going to readjust it so it reads plus 30 on that signal. Drop it down to 9. It's still reading 9. What you don't want is it never showing plus 30. So that's that done. Good. We'll do the deviation. Oh, let's do the squelch. So if you remember, that never opened. Go over to the attenuator controls. And turn the squelch to full. 3, 10, 30, 100. So I want the squelch to open, so I'll adjust the squelch preset till it does open. There we go. Drop it on the signal generator, it goes off, it's 100 microvolt, comes on. Right, we'll park that at 0.3 of a microvolt, put the signal generator to standby, turn the squelch down on the radio, set threshold. Signal generator back on, and it's still doing 0.3, so that's a really good squelch range. It's still got 0.3, and it's now 100 microvolts for top squelch. So the other thing he wants me to do, again, I'm not going to carry on with that because of letting it cool down properly. It's a hot day today. I really ought to have the air conditioning on in here. We'll take the power off. I'm going to do this power lead. So I've just got deviation to do and frequency trim. Just connect it a bit. So I think that's the thicker type. We're going to end up having to put an adapter plate on that, which is a job and a bit. I think it's the one which, yeah, it's not the square round, but that's what you've got to do. There's 3 types. This is the very early production. So that's what we'll have to do. That's a good half-hour job. Right, maybe tomorrow. We'll see how time goes. We're already about 7:30. So we'll rejoin this the next day. I've done the adapter plate, so it has the latest square round type. These 3D printed plates are relatively weak, and so always support the connection with the hot glue, so you've got the mechanical rigidity. So that then brings it in line with the latest square round type. As you're aware, there's 3 types on these. Nearly all of them are the square round, but really early ones have got that other one which would have been on here. Have I got a... just wondering if I've got one to show you. Is the one we did last? Yes, I have. It's that funny connector, which was obsolete before they would even finish making, which is why they had to change over. They're potentially a bit weak. So that's the one which this would have had. There's another one as well, in which case, to put the tail in, which we supply these, to put the tail in, you just file a little bit away and then it just clips in. So that's usually though on the fake Hong Kong version. So there's 3 types, and it's very frustrating. But you know, like 9 times out of 10, it is the square round. So the same applied with these Mustangs, because it's the same manufacturer. You know, with it being a Maxon. We've got some others here. Try not to drop my walkie-talkie. This other scrap set. Again, it's square round. That is what this is. And this one is again square round. So my 3 scrap sets would have been square round. We've got the sockets, we've got the tails, and we've got the power leads. And we've now got the mounting brackets, because Cybernet Brickworks in Holmfirth met up with me yesterday, because I'd lent him one of our Amstrad sets, and I'd lent him the details for the original bracket, and he's had them replicated. So that goes along with his other ones which he's had replicated, like the Rotel 220, and the of course that covers a pile of models. The Uniden 100, which covers a pile of models. The Uniden 200, which covers a pile of models. Maxcom 4E, and now the Amstrad. So I'll show you those towards the end. Let's get this hooked up, and hopefully, because the set was done, it just needed the deviation checking. But this takes about 40 minutes, so you know it's not a freebie. I'm really looking forward to the on-the-air test of this, because I think it's going to be really good. Right, power on. 13.8 volts into the test set. So our deviation, get it plugged into the other test set. Wow, 3.2. That needs to come down a bit. Wallow. That's very much 2.5 is an absolute peak. Good. Okay, so we've just checked the receive still there. We've checked the transmit. If I've got the walkie-talkie, I'd listen to how it is. I'll go and get that off the charger. We've done the crystal. So it was actually 3.4, it's now 2.2 to 2.5 peak. We did the meter, didn't we? I don't know if we did. And then I'll go and get the walkie-talkie and we'll go and just check. Oh, I'll show you the frequency. Are we on picture in picture? We are now. 27,79127, just slightly high, so it's got room to drop. And that's well within its travel. There's a lot more on that one. In fact, it's nearly at the bottom to get it to there. So that's brilliant. So a lot wrong with this, but not a lot wrong with it. It's all stuff that wears out, really. I mean, it should never have been doing 2.9 watts. So nobody's had the benefit of the radio doing its full power. But then they've gone and had the deviation gone beyond. So it's going to have sounded absolutely awful and caused bleed over, whilst being not as good on transmit as it could have been. 27,79127. Right, I'll go and get the walkie-talkie. Right, I'll take picture and picture back off. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. And what else? Where's his? It's the Palmer one. It's got all the screws in. Receives working through it. Testing 1 2, testing 1 2 1 2 1 2. A standard replacement Palmer mic, so excellent. We'll do it on our mic when we do the on the air test, and we'll go through on his. Right, we're onto his lids back on. I did go over it with isopropyl alcohol, so you can see it's a lot cleaner and there's less flux than there was before. And then we'll see the moment of truth and hope his speaker works. Did just clean the extension speaker socket, with the fiberglass brush, it just seemed a little bit iffy. Right. Top lid. It's certainly being in a smoking environment though. Right, I'll just you don't want to watch me put a pile of screws in. Right, swap the signal generator for the roof aerial. Oh, and then I'll show you that bracket from Simon at Brickvex. Really sensitive set this, full output, everything you could want. Not like you get today. Well, Nana Roger. It's morning, I think it's 10:30 in the morning, so they're not out of bed yet, as you can tell. Well, Nana Roger. So you can see by the wear on this, it's had a lot of wear. It has had a lot of use, hasn't it? But there we are. It's working splendidly. Just get one of these brackets. Just like this, it's a made in Japan one, but it's a bit later with the square round socket, as you can see. It's one of our faulty sets we've brought in, and that's the bracket, which of course is exactly correct. So there we are, Simon at Brickvex. I'll put a link to his establishment, and that set will be a forthcoming repair in the future. Right, we'll put the squelch on. It's not saying anything. Thank you for watching. We've got to go and tune the church organ. So that's the only CB fun today, apart from an on-the-air test for this. Thanks for watching the Amstrad 901 genuine Japanese Cybernet version from 1981.